Assalamu alaikum students. Today we will discuss the MCQs of circular motion, chapter 5 physics. First MCQ is, a simple pendulum vibrates with frequency of 10 vibration per second. The angle traversed in radian per second is. So here a simple pendulum has given which has a frequency of 10 vibration per second, which means that it completes 10 vibration in a second. So we have to find the angle in radian per second. So let's find the angle. Look, here is a simple pendulum, and from this position to again its initial position, it complete one vibration. But here 10 vibration per second is given. So let's convert this into radian per second. Here we know that one vibration is equal to 2 pi radian. Like if we consider this simple pendulum as in a circle, then from this position to here and again to its initial position, it completes one circle or 360 degree, which is equal to 2 pi radian. Okay, now here one vibration is equal to 2 pi radian. Okay, one vibration is 360 degree and 10 vibration means 20 pi radian. So here we have given that we have to find the radian per second. So it means that 10 vibration per second will be equal to 20 vibration per second. So here is the answer, that the angle traversed in radian per second is 20 pi radian per second. Next MCQ. Here, the angle made by an arc of a circle equal to twice of its radius. Now, understand this one. Look at the circle. In MCQs, they have said that the angle made by arc of a circle equal to twice of its radius. It means that the arc is its arc length. Okay, the arc length is twice of its radius. Okay, its radius and the arc length is twice of its radius. Now let's solve. Here we know that if the arc length is equal to the radius, look, arc length, its arc length, okay, is equal to the radius, then we said that it's 1 radian. The angle is 1 radian. Okay, but here in MCQ the arc length is twice the radius, which means that angle is equal to 2s. The arc length is twice, which means that arc length is 2s divided by radius. So it will give 2 radian. Okay, 2 radian. The angle will be 2 radian. So look at here, the arc length, when the arc length is twice of its radius, it means that the angle is 2 radian. So the answer is 2 radian. Okay, next one. The angular displacement by minute's hand of a watch after 5 minutes. So we have to find the angular displacement. Okay, what is angular displacement? We know that it's like this one is angular displacement. Let's find the angular displacement. Now look at here. What is the angular displacement? We can also call it as an angle. Okay, the angle in radian is called angular displacement. We can also call it the angle. So we know that 60 minutes is equal to 2 pi radian. Let's suppose it's a circle, and we know that a circle is of 360 degree. Okay, it completes from this point to again initial point. It completes 360 degree, and we also know that 360 degree is equal to 2 pi radian. Okay, 360 degree is equal to 2 pi radian. Now let's suppose we consider this circle as clock. Okay, we consider the circle as clock. Here is the 12, 3, 6 and 9. Now when a clock completes one round, when the minute hand of a clock complete one round, so it completes 360 degree, and in turn it completes 2 pi radian. Okay, so we will write it like 60 minutes is equal to 2 pi radian. Okay, when a minute hand complete 60 minutes from here to here, then it means that it has completed 2 pi radian angle. Okay, it has completed 2 pi radian angle or angular displacement. Okay, so after 5 minutes, how much angular displacement it will cover, or how much angle it will cover? Now look, take this 2 pi and divide it by 60 minutes and then multiply it with 5 minutes. Okay, now 5 ones are 5 and 5 12s are 60. Okay, now it will be like 2 pi divided by 12. Now 2 ones are 2 and 2 6 are 12. So pi by 6 radian. So after 5 minutes, the minute hand of a watch will cover pi by 6 radian. Look at here. If the options are in degree, then we will convert it like this. Like 60 minutes is equal to 360 degree. If the options are given in radian, then you will have to do this one process. Okay, if the options are given in degree, then you will have to do this one. Okay, so after 60 minutes, the minute hand cover 360 degree, and after 5 minutes then take this 360 degree and divide it by 60 and multiply it with 5. Okay, then cross this one, 0 will cancel, so 6 ones are 6 and 6 6 are 36, then 6 5s are 30 degree. So after 5 minutes the minute hand will cover, look at this, the minute hand will cover 30 degree angle. Okay, after 5 minutes it will cover 30 degree angle, and in radian it will cover pi by 6. Okay, you can also convert this pi by 6 into degree, like we know that here pi is equal to 180 degree. Okay, you have to memorize this, that 2 pi is equal to 360 degree, pi is equal to 180 degree, pi by 2 is equal to 90 degree. You have to memorize this. Okay, so pi is equal to 180 and divided by 6. Now 6 ones are 6 and 6 3s are 18 and 6 zeros are 0. So we will get 30 degree angle. It can also be converted like this. Okay, so the answer in radian is pi by 6 radian, and the answer in degree is 30 degree. Next one. Fourth, the angular velocity of R end of a watch is. Now find the angular velocity. Look, here is the angular velocity of R's end. Okay, we know that angular velocity is equal to angular displacement divided by time. So what is angular displacement? Now look, it's a watch, and a watch, when a watch cover like this, when R ends cover 12 hour, okay, when it starts from here and then complete 12 hour, we know that it is equal to 2 pi. Okay, the angular displacement will be equal to 2 pi divided by time. So how much time it has covered? The R end cover 12 hours. Okay, it covered 12 hours, so write it like 12. Time is 12. Okay, now 2 ones are 2 and 2 6 are 12, so pi by 6 radian per hour. Okay, the answer is pi by 6 radian per hour. But if the options are given in seconds, okay, if the options are in second, then you have to convert this hour into second. Okay, now what you have to do is pi by, we know that 6 hour contains 60 minutes and 1 minute contains 60 seconds. Okay, then multiply this one term, you will get the answer in radian per second. Okay, if the answer is, the options are in radian per hour, then you have to do this one. If the answer is in radian per second, then you have to do an additional step like this one. Okay, then you will get the answer. Next one. The ratio of angular speed of minute hand of a watch to the second hand of a watch. Let's find the ratio. Look, here is the ratio. First, angular speed of minute hand. Now let's find the angular speed of minute hand. We know that angular speed is equal to angular displacement or angular distance divided by time. Okay, we know that when a clock complete one round, like minute hand complete one round, then it covers 60 minutes. Okay, we know that when here is the minute hand, when it complete one round, then it covers 60 minutes. So 2 ones are 2 and 2 30s are 60, like this, radian per minute. So here, but look at this one. We have to also find the second hand, the angular speed of second hand. Okay, now angular speed of second hand is 2 pi divided by 60. Now look, it's a second hand. Okay, when the second hand complete one round, we know that it covers 60 seconds. Okay, now pi by 30 radian per second. But look at here, it's pi by 30 radian per minute and it's pi by 30 radian per second. What we have to do is just convert this minute into second. In order to find the ratio, you have to make the units same. Okay, but here, so here you have to convert minute into second. Now look, we know that 1 minute contains 60 seconds. Okay, now 30 multiplied by 60, so we will get like angular speed of minute hand is pi by 30 multiplied by 60. Now look, these units and this one, it's become same. Okay, now find the ratio. So angular speed of minute hand divided by angular speed of second hand. Look, the angular speed of minute hand is pi divided by 30 multiplied by 60, and here this one I can write it like division. Okay, and put the angular speed of second hand. Okay, it's pi by 30. Now what you have to do is just convert this division sign into multiplication, and this one will be like 30 divided by pi. Okay, when we convert division into multiplication, then it become like this one. So this will cancel this one and pi will cancel this one pi. Okay, the answer will be 1 divided by 60, or we can also write it like 1:60. Okay, so the ratio of angular speed of minute hand to the second hand is 1:60. Okay, well, this one look very longer, but I will suggest you to practice. Okay, practice will make you perfect, and then you will get less time to solve these questions. Okay, here is the sixth number. the dimension of angular velocity r. Let's find the dimension of angular velocity. Here we know that angular velocity is angular displacement divided by time. Look, it's angular displacement, okay? Now, we also know that this one is dimensionless quantity, okay? Angular displacement is dimensionless quantity. But how? Look, it's like this one. We know that angular displacement is equal to arc length divided by r. And both have the same units, like it is also measured in meter and it is also measured in meter. Or we can also use some other units, but both have same units, okay? Same unit of length divided by length. So it will cancel each other, and we says that angular displacement is dimensionless quantity, okay? But it has unit. It has the unit of radian, okay? It has unit radian, okay? Now look at this one. It's dimensionless. It means that we will put one here only, okay? And the time is t, okay? The time has the dimension. So the dimension of angular speed will be time inverse, okay? T inverse. So this one is the answer. Now next one. The direction of linear velocity to the angular velocity of a rotating body is always perpendicular, okay? It's like, look at here, it's a circle, okay? And its radius. Now the linear velocity is in that direction, okay? The linear velocity is in that direction, and we know that we use the right hand thumb rule to find the direction of angular velocity. So the angular velocity will be like this, okay? It will be like this. So it will be out of the page, okay? Out of the page, the angular velocity. So what does it mean? That the angular velocity and the linear velocity will be perpendicular to each other. They will have 90-degree angle, okay? Next one. A particle rotating in a circular orbit has a frequency of 50 Hz. Here is the frequency of 50 Hz. The angular speed of a particle will be. Now let's find the angular speed. Look at here. We know that angular speed is equal to angular displacement divided by time. And we also know that angular displacement is equal to 2 pi radian divided by time. Now, it's 2 pi. So, we know that time is equal to 1 over f. Or we also can write it like frequency is equal to 1 over time. We know that frequency and time are the reciprocal of each other. So, if I put here 1 over f, then it will be like this, okay? 2 pi divided by 1 over f. It will be like this. Now, bring this f into here, okay? Bring it here. Now, it will become this, okay? Angular velocity, angular speed of a particle will be 2 pi f. Now, put the values. 2 pi is equal to 2 pi and f is 50 Hz, okay? Now multiply 50 with 2, then we will get the answer of 100 pi radian per second, okay? This one is the answer. Now look, next. Here is the 9th number. An object revolving in a circle with variable angular velocity possesses. Now look. Now keep this in your mind that when a body is revolving in a circle, they will have always centripetal acceleration, okay? Centripetal acceleration will be always there. But here, in MCQs, that a body is moving with variable angular velocity. When a body is moving with variable angular velocity, it means that they must have linear acceleration also. They must have tangential acceleration also, okay? And we also know that tangential acceleration is also called linear acceleration. So option D is correct. They have all A, B, and C. Look at here. It's a circle. Now, variable angular velocity means that they must have variable linear velocity, okay? They must have variable linear velocity. When they have linear velocity variable, then it means that its angular velocity will also be variable, okay? Angular velocity is like this one. We can find it, this thumb rule, okay? It will be out of the page like this, okay? When it have the variable angular velocity, it means that it must have variable linear velocity. And having variable linear velocity means that it must have linear acceleration or tangential acceleration. And we also know that this velocity changes its direction on each point in a circle, okay? Changes its direction on each point. So from direction we know that there is centripetal acceleration also, okay? Now option D is correct. Next one. The length of an arc traversed by a minute hand of a watch 1 centimeter long after 15 minutes. What we have to find here? We have to find the arc length, okay? The S, arc length, okay? Now look at here. We have to find this. S is equal to arc theta. But here we have given that R is 1 centimeter. But the angle is not given. Only they have said that after 15 minutes are given. Now, how we will find this 15 minutes? Look at here. It's a circle, okay? A circle is like this, and we know that from here it's 0 degree, and from here this one, okay? In circle we know that it's 90 degree means pi by 2, and it's 180 degree means it's pi, okay? And it's 270 degree means 3 pi by 2, okay? And this one is 360 degree means pi, okay? Now if I consider this circle as a clock, okay? Now a clock like this one, let's suppose it's a clock, okay? And here is 12, 3 and 9 and 6. Now they have said in the MCQ that if the minute hand cover 15 minutes, then how much angle will be there? Look at here, how much angle is from here? It means that the angle will be 90 degree, okay? From 15 minutes here the angle will be 90 degree, okay? So for 90 degree we use pi by 2 radian, okay? Now put this pi by 2 here. Look, it's 1 centimeter. We have to convert it to meter, okay? So 1 centimeter is equal to 0.1 meter multiply the angle is pi by 2, okay? Here we don't need, here we will not put 90 degree, okay? We have to put pi by 2 is in place of angular velocity, angular displacement, okay? Keep this in your mind that we have to use pi by 2. We have to convert the angle into radian, okay? Now I can write it like this one. 0.1 meter is like, let's suppose in place of point I write 1, and here in place of digit 0, and in this place I also write 0. So the point will be finished here, okay? So I can write it like 1 over 100 meter and multiply by pi by 2, okay? Now I can also write it like, let's multiply these two, okay? 200s are 2 multiplied by 100, 200, so pi by 200 meter. So the arc length will be pi by 200 meter. So the arc length traversed by minute hand of a watch 1 centimeter long after 15 minutes is pi by 200 meter. Now the next one. Here the tangential speed of Rn of a watch 10 centimeter long is. Now we have to find the speed of Rn. And what is this? It's tangential. Means we have to find the V, okay? Now we know that V is equal to R omega, okay? It's a relationship between tangential speed and the angular speed, okay? Linear speed or angular speed. Now we have given that the radius is 10 centimeter, but what we have to find? We have to find this angular speed, okay? Angular speed can be defined like this. We know that angular speed is equal to theta divided by t, okay? Angular displacement divided by time. And we know that when R's end complete one round, like here, when R's end complete one round, then it will cover 2 pi radian, okay? Divided by how much time it covers? 12 hours, okay? It complete 12 hours during one round. So now 2 1s are 2 and 2 6 are 12. So the answer will be pi by 6, okay? Now here 10 centimeter is given as radius and the angular speed is pi by 6. Now find the answer. Look at here. V is equal to R omega, okay? Now when we convert this 10 centimeter into meter, we will get 0.1, okay? 0.1 meter multiply by pi by 6. So I can write this 0.1 as, put 1 in place of point and put 0 in place of 1, okay? So I can write it like 1 over 10 multiplied by pi by 6. So let's multiply this 6 and 10, we will get 60, okay? Pi by 60 meter per second. Now the tangential speed of R's end of a watch 10 centimeter long is pi by 60 meter per second, okay? It's the answer. Now 12th number. A particle moves in a circle of radius 5 meter with constant angular velocity of 20 radian per second. Then the magnitude of angular acceleration of a particle. Now we know that for angular acceleration we need the variable angular velocity, okay? But here the velocity is constant. What then? The angular acceleration will be 0. In case of angular velocity, like if it's constant, then the angular acceleration will be 0. Look, we know that its angular velocity is equal to angular acceleration final minus, angular velocity final minus initial angular velocity divided by change in time. Look, it's the constant angular velocity means that it's 20 radian per second. So if 20 minus 20 divided by time, so it will give 0 divided by time, and then 0 divided by anything gives 0 radian per second, okay? 13 number. A particle moving along a circular path has instantaneous angular and linear velocity respectively equal to 20 pi radian and 20 radian per second and 10 meter per second. The magnitude of centripetal acceleration. So here we have to find the centripetal acceleration, and the angular and the linear velocities are given. Its angular velocity and its linear velocity. Now find angular velocity, centripetal acceleration. Okay, here we know that centripetal acceleration is equal to v square divided by r. Here the linear velocity is given, it's 10 meter per second, but we have to find the radius. Now how we will find it? Like v is equal to, its linear velocity is equal to r omega, radius into omega means angular velocity. So r is equal to v divided by omega. Here the linear is 10 and the angular acceleration velocity is 20. Okay, so we will get the radius as 0.5 meter. Okay, the radius will be 0.5. Now here is the pi by 2 radius. So put here 0.5 and in place of v put 10. So 10 tens are 100 divided by 0.5. So I can write this like 1000 divided by 5. When I bring this point here, so the point will come, this one will be moved here. So in loop put 0. Okay, now I can write it like 1000 divided by 5, and 5 2s are 10 and 5 zeros are 0 and 5 0. So we will get the centripetal acceleration is 200 meter per second. Okay, per second square. Now the next one, 14. A body travels in angular displacement theta is equal to 10t plus 50t square. The magnitude of angular acceleration is, now look at here, we have given here an equation. Okay, it's the angular displacement. Now we know that the basic equation is like this: angular displacement is equal to initial angular velocity into t plus half acceleration, angular acceleration t square. Now think here that what will be the value of angular acceleration, that we will get 50 answer. Okay, now let's suppose I put here 100. Okay, if I put here angular acceleration is equal to 100, then I will get the same answer. Okay, listen, it's in angular velocity initial, it's 10. Okay, now put here 10t plus half, and in place of angular acceleration we will put 100. Okay, we will put 100. If 2 ones are 2 and 2 50s are, then look, 50t square, this one and this one, it's become the same. So it means that angular acceleration must be 100. Okay, angular acceleration must be 100 radian per second square. Okay, so you have to think like that. Okay, the options will be given like a is equal to 50, 100, 150. Now you will have to choose the option like which will become suitable for this one. Okay, which will become suitable for a. Now the answer is 100 radian per second square. Look, if I put here 150, then we will get the answer here 75 t square, which is not equal to this one. Okay, if I put here 200, then you will get the answer like 100 t square, which is not equal to this one. Okay, which is not equal to this one. If I put a is equal to 50, then you will get the answer here 25 t square, which is not equal to this one. So the correct is 100 radian per second square. So I will solve the remaining MCQs in the next video. Allah Hafiz.